Option in the 3D modelling drop-down list is the body operation tool. Now the body operation tool isn't a single operation but allows options to different types of operations, but they essentially are all operations on pre-existing bodies. And if you drop down the arrow on the right hand side in the details view for body operation, you will see a menu of all of the different types of operations available, and we'll run through these operations to give you some indication as to what they do and how they can be used. But the body manipulation tools option contains 11 different tools, as we've seen here, and the options vary depending on whether the bodies are active or frozen. So only certain bodies, for example, only frozen bodies as an example, can we perform slices on. We can't do that on active bodies as an example. Another example is cut and imprint, which aren't available when all bodies are frozen as well. We can select body operation and then set the type in order to determine the type of the body operation to be performed. So the first operation then is to mirror, which essentially will take a body and reflect it around a particular plane. So we need to select the body of interest for reflection. It can be a single or multiple bodies. We select the mirror plane, which is under here, mirror plane, and we select that particular plane, in this case the XY plane, which can be, once we click in this box, we can then click into the tree or the top of the tree in order to select the particular plane, depending on whether it's one of the default planes or a new plane that's been generated. And then it allows to copy over. There's an option to preserve bodies that can be seen here, which will, instead of just reflecting it and removing the original, it will allow to keep the original, so it's then preserved. For example, then we may want to unite them together. So for example, in this car case, we've got half a car around a symmetry plane, and we can effectively copy reflect, which is this mirror tool, select the plane for mirroring, so then we can create the other half of the car. At the moment these are two separate bodies because they're in two different colours, but if we mirror it, we can then go to one of the Boolean operations later on and then unite these two bodies together into a single solid for the car if we needed to. Another operation under the body operation tool is move, which moves and aligns selected bodies, and in this case we need to select the bodies of interest. So once we click on bodies, in this case one is one selected body, but once we click on that we can then left click on the body with body option chosen, and we can select the bodies for moving. We have the option, just as with the mirroring tool, to preserve the pre-existing body so it's retained in its original position if we still need it for any other operations, or indeed to retain it also for the simulation itself. We can set the source and destination planes, which can be seen here. The source and destination is plane 6 and plane 4, and these are the planes that the body is being moved from and to, so Design Modeler can understand how the bodies are moving. In this case we're taking this block here and we're moving it to align it with this other block. So here we're specifying these for two particular planes as the planes as the source and target for moving and aligning. Now you can see here that that we're moving to the red-green vectors of these sort of local coordinate systems, which always represent the planes. I mentioned this in some of the previous lectures, that we need to also always remember that it's the red-green vectors of the local coordinate systems that make up the actual planes on these graphical local coordinate system vectors. Okay, so moving down then, we also have some options on the body operations for move, align and orient, which are all under the move tool. So we can move, we can align, and we can also orient. So using the bi-direction option, you can align bodies using the alignment vertices for aligning axes and orienting bodies relative to each other so they're in the same relative position. So where we have multiple bodies or multiple parts, it's useful for aligning things correctly so that they're in the correct relative position, and we can use these tools in order to make sure that they are in the correct position. So we can see here we've got three bodies which are not in their correct positions relative to each other, and we can use the tools. Here we're using a move tool, and source and destination axes for alignment, in order to orient these bodies relative to each other, so they are then in the correct relative positions. So the user needs to select the bodies, pair the vertices for the source and destination move for orientation of the parts, and also the directions for source and destinations for align. Another body operation available option beneath the delete operation is scale. So we can select a particular body or bodies and choose those to be scaled, either scaled up or scaled down. And we can select the scaling origin. So this is the origin about which the scaling occurs, which could be the world origin or the centroid of the chosen body, for example, or a particular point. So this will affect how, in the way in which the body is scaled. So we can see an example here of the scaling. We have this plane. We may be looking at external flow around the outside of the plane, and we want to increase the size of the plane relative to the boundary. Rather than scaling down the outside body, we could scale up the inside, the plane inside. So here what we've done is we've taken the airplane and we scaled it up by double by selecting the body operation, a scale option, the body for scaling, in this case a world origin, and in this option here we'd have the scale factor, which would be this 2 value, in order to scale it up by 2 times. The next option available on the body operation is translate, but this slide also includes the rotate option as well. So we can translate a selected body in a particular direction. We simply need to specify the body, the translate option as part of the body operation, the body for translation, and we can also choose to preserve the position of the original body as well if we do the translate operation, so that remains where it was in the first place. We can specify a direction as coordinates, or a straight edge and a distance for translation of the body, and similarly with rotation we also specify an axis and an angle for rotation as well. Here we can see the axis definition and the angle down here for the rotation option. Another important operation is slice, which is under body operation, and this allows us to slice out one body from another. So we choose type slicer material, select the bodies for slicing, and opt for preserve bodies if we want to preserve the body that's being used for slicing. But here you can see that we've got 2 bodies here, and we're slicing out the aeroplane body from the spherical body in order to be left with the fluid region around the outside of the plane. So this is essentially cutting out this plane in order to leave us with the airflow region around the outside of the plane, for example, for a fluids aerodynamics analysis. Next we move on to the Boolean operations underneath body operations, and this contains some important tools for Boolean operations. Unite, subtract and intersect being some of the core tools. So unite will simply merge 2 or more bodies together and bring them together into one body. Subtract will subtract a target body, a tool body from a target body, to be left with the remainder of the target body. And we can also perform intersection as well, and there's some options under the intersection tool, as a union of all intersections and intersections of all bodies. Now here we can see some examples. On the right hand side we have these 3 bodies which go through each other, so neither of these bodies sees the other body, and then we can perform some operations to then allow them to see each other's position. So here if we perform an intersect, we're just left with the intersecting body. If we do the union of all the intersections, it allows not only the body which was overlapping from all 3 bodies, but also the bodies which were overlapping any 2 of the overlapping bodies. So we're left with this tri section in the middle. And we can also opt for a union of all intersection and preserve the input bodies, which leave this union section described just earlier and shown in this slide in the middle, but also the original parts of the bodies before the operation as well.